Hello, and welcome to the video portion for the Model-Based Definition Lab of ME123, often referred to as MBD for short. The base concept of MBD is that you can share an annotated 3D model with the manufacturers of the part instead of the 2D views that we rely upon for drawings. This gives the manufacturers a better understanding of the overall geometry without requiring them to have an expensive industrial SolidWorks license. Additionally, SolidWorks' MBD generation tools allow for easy implementation of geometric dimensioning and tolerancing, or GD&T for short, which often allows for more sophisticated tolerancing than standard techniques. We won't be getting into the exact meanings and definitions of GD&T, but we will be exploring the methods that can be used to incorporate GD&T into our MBD diagrams. Okay, let's begin with a model. Here I have this wall bracket. Before we jump into creating the MBD component, let's modify some settings. If we go up to the Options gear, we can pop over to Document Properties, expand Dim Expert, and we can modify some of the tolerancing. If our model is going to have the same tolerances for a lot of the dimensions, we can set the defaults here, which will save us a lot of time in the future. We can specify tolerancing for the sizings and locations of different features within the model. Here I want to modify the location dimension. So instead of plus minus 0.5, we're going to go plus minus 0.25 millimeters. Additionally, we can change the default type from symmetric to bilateral or general, whichever one makes the most sense for the model that you're working on. Last thing while we're here, we can also modify some of our display options. In this case, I want to modify it so that the datum note is specified on the surface itself instead of on the tolerancing block. Once we're done modifying all of our defaults, we can hit the OK button and move on to modifying our properties. Up here, under File Properties, we can specify some information about our model. If we pop over to Custom, we can set in some facts about the object. Let's begin by typing in part number, which is usually how they refer to the name of the component in industry. In the value box, we can then type in mounting bracket. This allows us to use a different name to describe the model than the SolidWorks file name, which may be completely decided by naming conventions that don't directly link to the model itself. Any other properties that are going to be the same across all configurations can also be input here, such as revision number and designer name, but properties that could change across configurations need to be put under the Configuration-Specific tab up here. Configuration-specific properties could be something like mass, which we can type in here, and then when you go over to the value and expressions, we can hit the drop-down and select the mass option from the list. The same thing can also be done for material, which could be linked directly to the material value for this model's configuration. That about makes sense for the properties that we would want to add for this demonstration, but you can include additional information as well. Once you're done, we can hit the OK button and begin the actual work. It all starts up here on the MBD tab of the ribbon. We're going to begin by hitting the Auto Dimension Scheme button, and then on the left bar we can choose our settings. For most models, we're going to be using the prismatic part type, but turned can be used for models that are primarily rotationally symmetric. Continuing down, we can pick our desired tolerance type. Here we're starting with plus and minus, and then we can determine how we would like to dimension patterns. These are all setting defaults, and we can add more dimensions manually later, but this is going to do the lion's share of the work for us. Continuing down, we can choose our datums that we would like to base our dimensions off of. So for us, the primary datum is going to be this surface here. The secondary datum is going to be this surface on the back. And the tertiary datum is going to be this surface on the bottom. The exact order of these isn't as important, but you want to make sure that each are defining a different direction. Lastly, we can choose the features that we want it to automatically dimension for us. I'm going to leave the simple hole box unchecked, since I want to do those manually. Now that everything's set, we can hit our check mark. See what happens. So we've got some green surfaces, we've got some pink labels, and the inner surfaces of these cylindrical holes have been left as is. The surface coloration is a way that we can tell which faces of the object have been fully defined and toleranced. If something's green, that means that it has all of the needed information to know where it is, and it has all of its associated tolerances, because everything that you intend to manufacture needs to have some tolerance associated with it. If it's not colored, that means that we have no information about the surface. And if it's yellow, that means that it's partially defined, so we're missing at least one bit of information to lock it in place. Surfaces can also turn red if they're over-defined or over-toleranced. If you're following the basic structure that we're covering today, that shouldn't happen, but that's what it means if something does turn red. Okay, so it looks like most of our model is pretty well defined. Let's take a quick peek around to see if we've ended up with anything extra. The model seems like it's supposed to be made with a single sheet of metal that's been bent here to get our corner. Realistically, we're only going to need one of these two fillet radii for the manufacturing process. In this case, I think that the inner radius is going to be the most useful, so we can actually delete the outer radius. We can then take a look at the status of the model by hitting the Show Tolerance Status button up here, and we can orbit our model to see that this fillet on the back has now turned yellow, since it's missing some information. Here we get to the really cool part of MBD. We can just leave this fillet like this. We want all of the key dimensions to be displayed, but if a dimension is not going to be important for the manufacturing of the part, or if the dimension is unimportant to the function of the model, we can leave it off. Since the manufacturers are going to have the model, they can measure what the radius is supposed to be if they want it, but here the outer radius is just going to be whatever it ends up being when that part of the model is being manufactured. This gives the machinists extra freedom, which decreases manufacturing costs, and it declutters the model, which helps make it easier to interpret the designer's intent. Okay, with all of that said and over with, let's move on to the holes. So, we know these holes are all going to be linked together, so we're going to want to use the pattern feature option up here in order to group them all into a single selection. I'm going to set this to collection, make sure that the find all and same face box is selected, and then left click to select the inside of one of these cylinders. Checkmark. Now, when I select size dimension, select this inner surface here, and choose the pattern option from the little pop-up, we can see that it automatically adds the 4x onto our dimension, which works to partially define all 4 of the holes, instead of just the one. Now on to GD&T. We're going to begin by providing our model with some basic location dimensions, which will act to place our holes on the surface without applying tolerances, since the tolerances are going to be defined via geometric tolerancing. Since these are basic dimensions, we can apply them however we like. Here, I think that chaining them from one hole to the next, and then from that hole to the side, is going to be the easiest to interpret, but realistically you could dimension these in any number of ways. You can tell that these are basic dimensions in one of 2 ways. The first way is that they have this little box around them, and the second way is that they don't have any tolerance directly associated with the numerical value. Now that we have those down, we need to mark our datums. Let's hit the datum button from over here on the ribbon, and we'll select the first datum as this back surface here. We can left click to place, and then left click once more to position. We're going to repeat this for datum B on the bottom surface, placed around here, and datum C on this side surface, placed around here. And now that we have those set, we can begin applying our GD&T control frames. If you want a control frame to define your position, it's often best to select the associated dimension first. Here, the 4x diameter of 10. Next up, we'll select the geometric tolerancing button from up on the ribbon. We want to generate a positional tolerance, so I'm going to select the little crosshair icon from our first pop-up menu. And then on the second pop-up menu, we can define our tolerancing zone. Since this is a positional tolerance, we're going to say that it has a diameter of 0.25, and from there we can apply our material conditions. In order to find these, we select the material condition option over from the left-hand menu, and then we can pick the maximum material condition circle. Positional tolerances need datums, so from here we need to select the Add Datum button. The first datum for position is the surface that the feature is on, in this case, A. We're going to need 2 more datums, so I'm going to select Add New, and then the second and third can be in any order, but they tend to be in alphabetical. In this case, datum B, and then Add New, and datum C for the last one. Let's hit Done. We can see that we have our very first control frame. Let's add the next ones. I want to specify that datum A on the back surface is flat within some tolerance. We don't have a direct dimension to associate with this, so I'm just going to select the geometric tolerancing button, and then we can left click to select the surface, and once more to place the frame. Flatness is our little parallelogram, so we'll select that, and then we want it to be flat within 0.1. Flatness tolerances don't have any datums. You can't be flat relative to something else, so this is all that we need to do here. Hit Done, and we've completed our second control frame. Let's do 2 more. I want to specify that surface B is perpendicular to surface A within that same 0.1 tolerance. I'm going to go back up and select our geometric tolerancing button, select the surface, click once more to place, and then the perpendicular option is right there. We'll plug in our 0.1, but this time we do need a datum. So we're going to select the Add Datum button from the bottom of the menu, type in our A, and then we can select Done. Lastly, I want surface C to be perpendicular to both datums A and B within 0.1. Same basic song and dance. We're going to go back up to our geometric tolerancing button, select the surface, click once more to place, and then pick the perpendicular option, type in our 0.1, and then we'll select Add Datum, have datum A as our first one, add new, and then we can type in datum B as our second. That's it for the datums for this one, so we'll hit done, and we can see that we now have all of our control frames. If you ever make a mistake setting up a control frame, you can double click on the frame, and then select once more on the box that you want to modify. Let's close these, and then we can select our tolerancing status once more to see that all of the important surfaces have turned green, except for the fillet that we left off earlier. From here, we can just go about cleaning things up. We can left-click drag on dimensions to move them around, and you can also do the same thing with tolerancing blocks. We can also double-click on any annotations or dimensions if we would like to modify them. Specifically, this can be handy to modify the tolerance. If the tolerance is different from what you would like, we can change its type from the drop-down up at the top. We can change the numerical variation here, and we can even change the precision. In addition, we can move which view different blocks and dimensions are visible from. You'll notice that all of these dimensions and blocks are aligned with the 3 primary planes. In order to change a plane that the annotation is aligned with, we can right-click on that annotation, select Show Annotation View, and then pick the plane that you want it to be aligned with. In this case, I want this block at the bottom to be aligned with our front view. Now, just because we're working on an MBD model does not mean that you can ignore good drawing practices. The MBD file still does come with default views, so it's important that our annotations are clear and legible in the views that we want to use. Via the view cube, let's set ourselves to the front view so we can make sure that all of our numbers are legible. Here we've got some slight issues with this dimension, so I'll move that down, and we'll do our best to minimize crossings and to make sure that each one of these blocks is easily recognizable as to what it's supposed to be referencing. Once we've cleaned things up on the front, we can use the view cube to reorient ourselves to the right view and repeat the process, moving things so that we don't have any numbers overlapping, and doing our best to position the dimensions in locations where they make sense. Excellent. At this point, we can produce our views. This is done by activating the 3D Views tab down at the bottom of the screen. From here, we can orient our model to the appropriate orientation. Let's begin with an isometric, which we can access via Control 7. And once you've got your model in the correct position, we can select the Capture 3D View button. On the left-hand side, we can name the view. In this case, let's call it isometric, and we can also choose the configuration, display state, and which annotations are visible. The isometric traditionally has all of the annotations visible, so we can make sure that each one of these options is selected blue. Next up, we can do the front views and the right views. Using our gimbal, I'm going to select the Z-axis to give us a front view. We can position it properly in the view window, and then select Capture 3D View. Likewise, we'll name this one the front. Oftentimes, in these views, you're going to only want it so that the relevant annotations are visible. So here I'm going to deselect the right, top, and notes so that only front is available. From here, we'll hit our check mark and repeat the process one more time on the right view, selecting the X-axis on the gimbal, selecting Capture 3D View, and making sure that only the right view is selected. Rename to right, hit our check mark, and we're good to move on to the last step, producing our 3D PDF. The 3D PDF is exactly what it says on the tin. It's a PDF that has 3D capabilities, and one of the best ways to view it currently is the Adobe Acrobat Reader, which is free to download on your own, and is available on the remote desktop service. We can begin making this file by expanding the bottom bar so that we can see all of the buttons, and selecting the Publish to 3D PDF option. At this point, we can choose the template that we would like. Often I find that Approvals Notes is a pretty good option. And then we can hit the OK button. There we go. After a moment, the generator has loaded. First, we have to add in the views that we want. We have the Primary and Thumbnail Views box up at the top. We're going to want to select this via left click, and then select the views that we want it to add. It's automatically taken the first view that we've given it, and we can also select the front view and the right view to add them to the carousel. From here, we can add in some of the custom properties that we've created earlier. We'll hit the drop-down under Custom Properties field, and then we can choose the property that we want it to use. In this case, for part number, I'm going to left-click this box here, left-click our drop-down, and then choose part number from the list. We can repeat this process for any of the other properties that we've filled in, but you can see that some of them get added automatically. Once you've made all of your decisions, we can hit our little green check mark up here at the top left, and choose where we would like it to save. I'm going to name mine MBD PDF Demo, save, and from here we can open our PDF. You're going to want to begin by making sure that you open it with Adobe Acrobat Reader. Many of the other options that you can open PDFs with do not yet support 3D PDF functionality. Once the PDF is opened, we can access the 3D PDF functionality by hitting the drop-down under Options and selecting Trust this document one time only. At this point, we can choose the view that we want to see from the carousel down at the bottom via left click, and that gives us full access to the model that we've created. You can left-click drag to orbit, scroll wheel functions to zoom, and we can choose some additional navigation options via this drop-down over here. You can even access the 3D measurement tool, which is going to allow us to measure a distance from point to point on the model, giving us some additional information on top of all of the dimensions that we've used. If you would like, we can even add in some additional comments over on this box here. You just want to make sure that you save your file if you do add any comments. Well, that about covers most of the details on making and distributing MBD files. I hope that you've learned something interesting, and do feel free to experiment with the different options and tools that we may not have covered directly. Have a good one. We will see you again next time.